Okay, so today we're going to talk about roots and zeros, and we're going to find polynomial functions to fit our graphs. So we're going to look at a graph, write a polynomial, and then you're going to be given zeros, and you're going to write a polynomial from that. So the first thing we want to look at is this recall. How do you write the 0, 1 as a factor? So if you have x is equal to 1, this is what it's saying. How would you write that in a factor? Remember, it's x minus 1, because if you set that equal to 0, that's when you would get x is 1. What if you had negative 1? What would your factor look like? X plus 1. Okay, and if you had 0, you could say x plus 0 or x minus 0, but doesn't that just simplify to x? Okay, so whenever you are writing a factor, your factor form is going to be x minus the value of a, where a is your 0. Okay, that way if it's a positive 1, it's x minus 1. If it's a negative, minus a negative becomes plus. Okay, if it's 0, x minus 0 is still just x. Okay, so you can simplify it there. So you're going to write a polynomial that could be represented, and it should say by the graph below. Okay, so if we are going to write a polynomial, what we're going to do is we're going to write the factors, the zeros as factors, and then we are going to multiply it together. So the zeros are the same thing as what on the graph? Yep, so the zeros are your x-intercepts. Okay, so we can find them from this graph here. Okay, there are 3 times it crosses the x-axis. Okay, will you guys write out what those 3 are? And then we're going to write those in factor form. So write down what those 3 are. And Elijah, what did you get for your x-intercepts? Yep, -3, -2, -1. So now we just have to write those as factors. Okay, so if you have -3 minus a negative is plus. Minus -2 would be +2. Okay, so what we're going to do is we are going to multiply those together. When you multiply binomials, you are going to FOIL, which is a way to distribute. Okay, and you can choose any 2 that you want to FOIL together. I like to do the back 2 first. And it doesn't matter what order you write those in, you're going to get the same thing. The reason why I like to do the back 2 is because I'm going to have to distribute. So if I'm distributing, I like to distribute from the front side. So if I FOIL, x times x is x squared. The middle you can do in your head, the 2x and the 1x would be 3x, and then 2 times 1. Okay, and then this is just a skill we did earlier this year. So we distribute x to get x cubed plus 3x squared plus 2x. Then we're going to distribute the 3. I like to line those up so when I'm ready to add straight down, I already have my like terms. So you're going to distribute 3 to the trinomial, multiply every value by 3, and then we just add straight down to combine our like terms. Okay, when you combine your like terms, remember the variable stays the same, it's just your coefficients. And then we are just going to call the polynomial f of x, call it p of x. Okay, this one, some equation there. Okay, f of x, y, p of x, all of those are great. Okay, so if you are given a graph, you can find your x-intercepts and then factor. Okay, remember that the graph does not show you the imaginary values. So we are also going to create polynomials when you have imaginary roots. So yesterday we talked about how we have these complex conjugates. So if you have a plus bi, the complex conjugate is a minus bi. And then the conjugate, when you have a radical, if you have a plus b root c, then a minus b root c, that is also a root. Okay, so why do you think this is true? Why do you think if you have a radical that you are always going to have the conjugate as a 0 as well? Same thing with the imaginary. Why can't I just have one imaginary root? So we're going to think about that for a second. Okay, and then I want you to turn to an elbow partner and share your thoughts. Even if your thoughts are you're not sure.
I know that.
All right. Seems like a lot of you are doing a nice job understanding this. Okay, so Noah, can you tell us what your group was talking about? Why this is true?
As each square root, you can either have a value of positive or negative.
Yeah, so the imaginary numbers come from square roots. So when you do the square root, you are going to have that positive and negative value. Hi, Cocoa Cart.
We have coffee.
But all right, I'm going to pop out in just 1 second. Okay, so this is true because both imaginary and irrational roots are generated from square roots, and that is going to result in both a positive and negative solution. Okay, so I'm going to have you guys write that part down. Okay, and then for example 2, I want you to see if you can do steps 1 and 2. Okay, so step 1, list all of your zeros. So I gave you those zeros, but there could be some that are missing. They're bringing like a little cocoa cart around for 50 cents. Okay, how do you think we did? All right, so you had 0, -2, and then 3i. So when you wrote the zeros, how many zeros should you have? Yeah, great. Okay, so 0, -2, and 3i. So your zeros are 0, -2, 3i, and -3i. Great. Okay, and then you rewrote all the zeros in factored form. And even if you weren't sure about that last one, right, we've already talked about your factored form here. So if it's 0, you can write x minus 0, or you can just write x. If you have x minus 2, that will be x plus 2. And then if you have 3i, it's x minus 3i. And then minus a -3i would be plus 3i. Okay, and then once we get here, what do? We're going to FOIL. Now think about what you're going to FOIL together first.
Plus or minus I, or plus the plus and minus.
No, but I think I know what you're thinking of, and that's going to happen when you multiply these together. So when you're writing the simplest polynomial function, you want to have the polynomial of the least degree. So the least degree for this, if you have these 3 zeros, you need to have a degree 4 because the I comes in pairs. Okay, when you FOIL these together, you want to FOIL the conjugates together first. Okay, so it says use FOIL and the distributive property. Always FOIL your complex roots together first. And then once you do that, you are going to plug in -1 for I squared. Okay, so I want you to simplify that. Okay, so when you FOIL this together, you get x squared, and then think about what happens here. If you have -3i times x and then plus 3i times x, what happens to those? They're going to cancel out, okay? So when that happens, you can do that part in your head, okay? That's just going to make 0, so you don't have to write that down. And then -3 times 3 is -9. I times I is I squared. And then we're going to substitute in that -1. Okay, so when we simplify that, this is going to become x squared. -9 times -1 is going to be +9. Okay, and then we're going to simplify here. So you just have to distribute. Okay, so you'll get x squared plus 2x. We're just going to drop that down here so that we can multiply. And do you notice it's another binomial times a binomial? So when that happens, you can FOIL. And then we're going to write the polynomial in standard form. Okay, and then you always want it to be an equation, so f of x is fine. So can you go ahead and FOIL that, put it in standard form? All right, so then we should have x to the fourth, and then x squared times x squared is x to the fourth. Inside we have 2x cubed. Outside we have 9x squared. And then 2x times 9 is going to be 18x. Okay, what questions do we have on part A here? With the multiplying. Okay, so anytime you have an I squared, remember we want to simplify that by plugging in -1. Okay, and then anytime you're multiplying your polynomials together, you can FOIL or you can distribute. Okay. All right, so sometimes you have zeros that aren't just one value. So with the ones we've done before, they've always been a monomial term. They've been one term, but that's not always the case. So we've seen roots where you have plus or minus in them. We're going to see them in this as well. So if the zeros are binomial zeros, we're going to have to distribute a negative and regroup. Okay, so I'm going to show you how to do this. You have to distribute the negative, and then we're going to regroup with parentheses. Okay, an easy way to remember that you need to do something extra is that the binomials need to have brackets. Okay, because we're going to do a few steps with this one. Okay, so if it's a binomial, we're going to be using brackets here. So the first step is to list what zeros you have. You have 5, 1 minus root 5, and if you have a root, that means 1 plus root 5 also has to be a 0. That means your simplest polynomial is going to have a degree of 3. Okay, so x cubed should be part of your final answer. The second thing we're going to do is write these in factor form. I'm going to help you with that. Okay, so in factor form, you have the form x minus a. So the first thing we're going to do is the 5. So x minus 5. And then the binomials are going to be a little bit different. Okay, so if it's a binomial, you're going to use a bracket. We're going to keep that form x minus, and then we're just going to plug in our zeros. So we have 1 minus root 5. We're going to keep this form of x minus my 0. And then we're going to do that for the second one as well. So the form is x minus whatever your 0 is. From there, you are just simplifying using your algebraic rules. So if you have a negative in front of the parentheses, you're going to distribute. We're going to do that together as well. Okay, so then this is going to be x minus 1 plus root 5. And I want you to distribute for the second one. And then I'm going to show you how we're going to regroup. Okay, so you are just distributing. So you distribute your negative. And then do you notice any values that are the same in both? Yep, what else though? Okay, so when we regroup, we're going to regroup the non-radical terms together, which should be the same. Okay, so you got x minus 1 minus root 5. The regrouping is just going to be grouping that non-radical term together, and those should be the same. Okay, this x minus 5 is still in front. You don't have to write it out every time. Okay, we're just going to concentrate on multiplying these conjugates together first. The reason why we regroup is so that we can FOIL these together. Okay, so when I FOIL, you know how we do the first times the first? We're treating this as one term. Okay, so we're going to do x minus 1 times x minus 1. So we're going to do x minus 1 squared. Okay, so first times first is x minus 1 squared. And then here on the inside, you'd have plus root 5 times x minus 1. On the outside, you'd have minus root 5 times x minus 1. So again, those would cancel out. So if you've done this correctly, those should be conjugates, and the middle should cancel out to get 0. And then when you multiply root 5 times root 5, okay, you are just going to get, well, the square root of 25. What's the square root of 25? 5. So root 5 times root 5 is 5. Positive times a negative is a negative. Okay, and then we're going to keep simplifying this. Okay, so we're going to do the x minus 1 squared. You don't have to write that out twice, but if you like that because it helps you FOIL better, you can. Okay, so if you FOIL x minus 1 times x minus 1, you'll get x squared. Minus 1x minus 1x is minus 2x. Negative 1 times negative 1 is plus 1. Okay, simplify it one more time. I won't forget. I just want to finish. Okay, so if you combine your like terms, you're going to get x squared minus 2x, and then 1 minus 5 is negative 4. And then from there, we're going to drop down this x minus 5, okay, and we're going to distribute, okay, so just like we did in the last one. So I want you to multiply everything by x, and then we're going to multiply everything by negative 5. Okay, and when I do this, I like to line up my like terms, so you're welcome to do the same. As I'm doing this, I'm thinking about my signs, a negative times a negative, what that's going to look like. I'm adding straight down. Okay, and then my final answer is going to be with an f of x. Okay, and then Elijah, what's your question for me? What's that? Like here?
Yeah.
So what you're distributing is what's in front. So this isn't multiplied to that, so you won't distribute. It's the negative 1. So you're multiplying both of these by the negative 1 that's on the outside. Right, it would have to be multiplied by that. I thought you were going to ask me if you can distribute these to all of those, and you can. It just takes a lot more effort. But you could, and you'll get canceled. All right, so I want you guys to try the first few steps here. Okay, so step 1, write out your zeros. Okay, so if you have negative 2i, that has to have a partner. The only ones that don't need a partner are just your rational numbers. 5, 0, negative 2. Those don't need partners. They only need partners if they have a radical or an I. Okay, and then once you have those, you're going to write them in factor form. Okay, do you guys think you can do that? Without me? Let's give it a go. And then you can start multiplying them together. Yep, your form for the factors is always x minus, and then when you distribute, we simplify. Whenever you have a negative and it's just one term, we simplify that in our head. So when you're doing the factor form, if you do x minus a negative, what does that become? Plus. So we're doing that part in our head. That's why it's plus. It really is minus the negative. And then here is just minus your 2i. Okay, if it's a binomial, you need your brackets. So x minus 1 plus root 2. Okay, x minus 1 minus root 2. Okay, the factor is always x minus, and then we simplify. It's only going to change to plus if that's what happens when you simplify. Okay, and you can decide what you want to simplify first. You're going to work with the conjugates together. This one is going to be a little simpler when you FOIL. So you get x squared. We know the middle and the outside, those are going to cancel. 2 times negative 2 is negative 4. I times I is I squared. And then we always are going to substitute in that negative 1. So this becomes x squared plus 4. Okay, our distribution process here, we just distribute the negative to the 1 and the root 2. Okay, when we distribute here, you end up with a plus root 2. And then we're going to regroup those together. Okay, so when you FOIL, the first term in each one should be the same. So it's x minus 1 and x minus 1. So you have x minus 1 squared. Inside and outside are going to cancel. And then the square root of 2 times the square root of 2 is 2. And this should always be a minus because you should always have opposites there. Okay, and then when you're breaking this down, we're just FOILing. X squared minus 2x plus 1 minus 2. Okay, and then we're going to distribute. Okay, and I know for some of you this is going to be quicker than others. That's fine. Okay, so we're going to distribute the x squared and distribute the 4. Okay, so if I distribute x squared, I get a trinomial. Here, if I distribute 4x squared, okay, I'm going to line that up. Minus 8x minus 4. Okay, and this guy just dropped down there. Alright, and then your homework tonight is a worksheet, which means it is mandatory. And I'm going to pass that out to you. Okay, so just remember, as do in Google Classroom,